Hi everybody, and welcome back to video number 2 in chapter 13. When we left off, we were looking at P&G's weighted average cost of capital. And here's the calculation here of 5.83%. I'm not sure that you would be able to follow how that was calculated. So I'm going to jump to an Excel spreadsheet, which I will also include in the module for your viewing pleasure. Anyway, so here's that spreadsheet I talked about. And as you can see, I simply copied over this page here from the PowerPoint to show you how it's calculated. So you see this cost of debt is shown as after tax here. We'll talk a little bit more about that in a second. But we're weighting it 11.2%, as you see here, as well as the after-tax cost of equity and the after-tax cost of preferred stock, given in the problem here as after-tax. So we simply multiply these after-tax costs times their weighting, and you get these weighted average costs. And then we add those together, and it comes out to 5.83, as you can see here. Now also, you will see that they're using some discount factors here, and I wanted to quickly go through how those are calculated before we return to the PowerPoint. So in this case, in this PowerPoint, we take here's our years, 2019, 2021 through 23, and we start, where do these discount factors come from? Well, here's how I calculate them. I take this period 0, as I call it. There's no discounting in period 0, which is 2019. And then 2020, 21, 22, and 23, there is. So I'm going to multiply this previous cell times the discount rate, which is the weighted average cost of capital we had in the previous model, in the previous spreadsheet. So that's all I'm doing here, is I'm multiplying this cell by 1 plus the discount rate. And I copy that down. And if you'll notice, if you're Excel people, you'll notice that this is an absolute reference, where this is a relative reference. And so now, all I do is divide that factor into 1, which is what I've done here. We're taking 1 and dividing it by this factor. And that gives us our discount rate, which you see is the same as what they put in this forecast period here. So anyway, hopefully that helps you understand those two concepts a little bit better. Okay, back to the PowerPoint. So now hopefully this 5.83 makes a little more sense. Whoops. That 5.83 makes a little more sense. But I do want to talk a little bit about the cost of debt. Here we've done the same thing. We've weighted our short-term and long-term debt here and here by the percentage that we have in those categories and their rate here and here. And that gives us an average of a shade over 2%. But that's not an after-tax cost. We do get our tax shield on that. So what we do is we multiply that 2.01 times 1 minus the tax rate. So that's what we have done here. 1 minus 22%. What is that, about 78%? So we're going to divide 2% by 78%, and we come up with our after-tax cost of debt, which is 1.56% up here. Okay, and the other calculations I think you'll follow pretty easily, so I won't spend any more time on that. Now, let's take a look at the applying this discounted cash flow model a little bit, involving 5 steps. we're going to forecast and discount the free cash flow to the firm for the horizon period, and then we'll forecast it out even further to the terminal period. And we're going to sum those present values, which I discussed a little bit in the Excel spreadsheet, for both the horizon and terminal periods to yield the firm's enterprise value. And then we're going to subtract any net non-operating obligations, NNO, and non-controlling interest, NCI. All right, I think you can follow that okay. And then we're going to divide the firm's equity value by the number of shares outstanding, and that should give us a pretty good handle on the stock value per share. So let's see how that works. So the ROPE model defines the firm's value as the sum of those two components, then net operating assets plus the present value of expected ROPE, residual operating income. Okay. And then net operating assets then is the foundation of the firm value under that ROPE model. And to the NOA, the ROPE model adds a second term, the present value of the expected residual operating income. Now, the second term adjusts for any possible undervaluation or overvaluation of net operating assets. Pretty complicated, as I think you'd agree. So, here we're going to take the expected residual operating income, and we're going to define it as net operating profit after tax minus the net operating assets times the R, where R is our weighted average cost of capital that we just calculated at 5.85% in this case. You should think of weighted average cost of capital as a hurdle rate, where, as is described here, a hurdle rate, that's the minimum the stockholders are going to want from their investment, 5.85%. And the residual operating income, therefore, is the net operating profit that's over and above that weighted average cost of capital. Very important to understand that, so be sure you've got this one down. So the companies that earn profits over and above that hurdle create value for the stockholders. This is the concept of residual income then. Operating income earned over and above the minimum amount of return required by the investors. And that required return is the same as the weighted average cost of capital in this particular example. Okay, so like the discounted cash flow model, then we have 5 steps for the ROPE model. And here we forecast and discount the ROPE for the horizon period, for the terminal period, and we then sum those present values up to yield our enterprise value. And to determine the equity value, we subtract out those non-operating obligations and non-controlling interests. And same as before. Then we divide the firm's equity value by the number of shares outstanding, and that should yield us the stock value per share. As you can see, that stock value looks forward in time. It's not just a static amount that looks at today. So how shall we'll illustrate this ROPE model for Procter & Gamble here. And here it is. Now, we've gone through how we came up with these discount factors, and here's our terminal period calculations here. So we've cumulated all these present values of the horizon ROPI, and that's these. Boom, 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 boom. And now the present value of the ROPI is going to be calculated. I think we'll show you how to do that here. We're going to take this 91.55, which is here. Here's our weighted cost of capital. Here's the rate at which we think dividends will continue to increase per year annually. And then we discount it at the 2023 discount factor. And that gives us 190,558. We add to that the net operating assets, and that gives us the total firm's value. We're going to back out the net non-operating obligations here, and the net controlling or the non-controlling interests here. We're backing those out of this total firm's value. And so the firm's equity value, 267,147. Divide that through by the number of shares outstanding, and we get a calculation of what we think the firm's value, stock price per share, should be, $106.66. And the stock price in June was a shade over that at $110.49. So you could see this method is fairly accurate. All right, let's look at the discounted cash flow in ROPI and see what that yields as far as identical per share estimates. In this case, so long as the firm is in a steady state, and what that means is when net operating profit after tax and net operating assets are growing at the same rate each year, they're going to yield the same per share estimate. But when these conditions are not met, the two models will yield different valuations, which could happen when we predict different terminal period growth rates, or when profit margins are predicted to change. In practice, we often compute the estimated stock values from several models using these qualitative analysis to determine an overall price estimate. Okay, that represents a good place, I think, to stop for this video. And when we return, we'll take a look at how the equity valuation models can inform managerial decisions. Until then, bye for now.